Day one, we talked about the solution to a system of linear equations is when the two lines intersect. Okay, so in the last chapter, chapter 6, linear functions, we were learning how to graph these equations. And what we're going to be doing is translating that knowledge into this section. So basically, you're going to get two equations, and you're going to have to find the point that satisfies both equations. In other words, it's the point that is on both lines. So if you stare at this picture, what point do those two graphs cross at? So this guy right here, it's 2 to the left and 3 up. So this is the point. This is the solution right here. All it is a point of intersection. So negative 2 comma 3 would satisfy. It's in bold font right up there. That's the one you want. So when it means to satisfy is if you put those into the equation, the equality would work out and everything would look good. So there's one point where two lines could possibly meet, and that is the solution. So for this question, they want us to find the equations of the graphs. So my recommendation is that you stick to mx plus b when you're given a graph. Usually that's the best way to go. So for the red line, what's the y-intercept? Up here it's 5. And what's the slope of this line? What's the slope of this line, the red line? Make a triangle. If it goes over 1, you go up 1. So the rise over the run would be 1 over 1, which is just 1. So the equation for the red graph would be 1x, which we don't have to write the 1, 1x plus 5. Okay, and for the blue line, what's the y-intercept? 1. And then what's the slope? Pick a good point. Over 1 and down 1. Over 1 and down 1. So what's the slope for the blue line? Negative 1. So then you would have y equals negative x plus 2. Oh, pardon me. Plus 1. Thank you. So then when you go to check if this is a solution, you have to plug that point into both. So for the red line, the y is 3, the x is negative 2. Is that equality true? Negative 2 plus 5? That's good. And for the blue line, when you plug in a y3 and x of negative 2, you get a negative negative 2 plus 1, which is 3 as well. So this is good. So when I plug those points in, that's when you're checking to see if it satisfies the equation. When you plug in x, y, and then you see if the equality is held true. So this coordinate negative 2 comma 3 is the solution that satisfies both equations. So that's what we're going to be doing this whole lesson. You take your line and the graph and you find out where the 2 points or where the 2 lines cross at what point. So I'm just going to... Okay, well, let's go to the next slide and take a look. So this first section is a bit of a warm-up. Just going to be a little bit of a review for isolating into the y equals mx plus b format. So this gets us into... This is the format that we want to be. So we can easily graph. We can easily identify slope and easily identify y-intercept. Okay, so isolating y. That means we want y by itself. So you do it in 2 steps. First, you isolate the term involving y. So the term involving y is 3y. That 2x has to be removed. On the left, you have some addition of terms. So to move the term to the other side, we use addition and subtraction. Positive 2x on the left is a negative 2x on the right. That's the first step. Second step, we've got to divide by 3. So 10/3 is not a nice number, 2/3 is not a nice number, so I just leave them as fractions. You can easily identify the slope. The slope is negative 2/3. The y-intercept is 10/3. For the second equation, isolate the term involving y. Which one is that? 10y. So if you leave that guy alone on the left, what moves over? The 2x and the negative 5. So make sure that you switch the sign when you go across the equals. So 2x becomes negative 2x, and negative 5 becomes positive 5. Now I need to divide by 10, and you get 2/10. What's 2/10? Yeah, negative 1/5. And then 5/10, 1/2. Good. So right now, maybe you want to jot that down on the side. How I got the 1/5 negative would be 2 on top of 10. 2 on top of 10. They both can be divided by 2. You get minus 1 on top of 5. And for the other one, we had 5 on top of 10. Both are divisible by 5. You get 1 on top of 2. So just reducing the lowest terms fraction. Now C is a little bit different. Why is C a little bit different? Because the y is on the right-hand side. And it's positive on the right-hand side, so I'm okay with leaving it there. So I'm actually just going to move the 1/3. So stare at that equation for a second and just try to figure out what I did. I'm trying to isolate the term involving y. So I want the 2y to be by itself. So I just subtract 1/3 on both sides. Subtract 1/3 on both sides. Now what do I got to divide by? You got to divide by the term, the coefficient in front of y. Divide by 2. So you get a half x, because it was originally 1 whole x. So 1 divided by 2 is half. And then here you have to do a half of a third. And I can help you on the whiteboard with that one. A half of a third. So you already have 1/3. And you want to divide by 2. So this 2, it's got to be put down here. So you get 1 on top of 6. Half of a third, 1/6. So that's an important skill. Like, I'm going to put a huge star on this, because when we learn to use this calculator tomorrow, We're going to use these tomorrow for the first time for the actual graphs. At the very top left button on this calculator, very top left button, it says y equals. And in order to type in an equation into the graph and calculator, you have to have y by itself, y equals. So this is a very important skill that you have to have. So huge star on this one here. Very, very important. Okay, so now without technology, because tomorrow we're going to do it with technology, but today's without. We're going to take these two equations, we're going to graph them, and then we're going to find out where they meet. The first one is already isolated into mx plus b. So the first one's good. The slope is 2, and the y-intercept is -5. So that one's already done. We can graph that quite easily. Always start with the y-intercept. So where's the y-intercept going to go? One, two, three, four, 5. Down. There's -5. You guys okay with that spot? Now the slope being 2, that means every time x goes up by 1, the y value goes up by 2. So this would be like $2 for what? Maybe it's $2 a ticket, or $2 for a cookie, or $2 for advice. Every time you give advice, you charge $2. Okay, so like if I gave advice 3 times, you'd get how much dollars? 6. So every time it goes up by 1, it goes up by 2. So that's just a ratio. It's a proportion. Some people like to put the 1 on the bottom. Then it helps remind them that if I go 1 to the right on the graph, then I got to go 2 up. So there's the next point right here. Why is that the next point right there? Because as I go 1 to the right, I go 2 up. 1 to the right, 2 up. And you can draw a bunch of these points. Or you can just use a straight edge. As long as you're accurate. I'm just going to draw a whole bunch of dots. You can even go left. What happens if you go 1 left? Well, you got to follow the pattern. It's a straight line. So 1 left, you got to go 2 down. Good. And 1 left, 2 down. And it should be connected with a straight line. Except on my software here, it's not too bad. Okay, so I'm actually just going to ignore the lines because it kind of is ugly. But you should have a line in there with an arrow on both ends. Okay, so that's the first one. How about the second graph? So I'll switch color. Maybe let's go to blue. Let's try this one. So you have 2x plus 3y equals 9. If I want to graph this on my grid, I'm going to have to get it into mx plus b form. So what's the first thing I should do? Isolate. So where's that 2x got to go? Okay, so what do you have on the right? Negative 2x plus 9. Good. And now what do I divide by? 3. So then I have 2 on top of 3x, and then 9 on top of 3. 9 divided by 3 is a nice one. You get 3. So when you go to graph this one, you have the slope is minus 2/3, and you have the y-intercept at 3. So when you go to graph that, where should you start? Start at 3, right? So way up here. Now this time, when you look at this slope, remember rise over run. So you always go to the right with x. And then because it says -2, you go down. So 3 to the right and then 2 down. 1, 2, 3, 1, 2. Oh, that spot hits both. That's actually the answer right there. 3 to the right and 2 down. 3 to the right and 2 down. And if I go to the left, I got to go left 3 and up 2. So 1, 2, 3, 1, 2. 3 left and 2 up. 3 left and 2 up. So you would imagine two lines crossing. What's the spot that is shared between both lines? It's the spot I have circled. So give this one a circle. And that spot is 1, 2, 3 to the right and 1 up. So this is the solution right here. That's the solution to the system. So let's see if it works out. Let's use x is 3. In the first equation, 2 times 3 is 6. 6 take away 5, y is 1. It worked out. Try the second equation. Well, the second equation, if you put in a 3 for x, 2 times 3 is 6, and then put a 1 there. 3 times 1 is 3. So 6 plus 3 is 9. So it worked. That's all it is. Where the two lines meet. People still need the notes? Okay, I'll just pause. Okay, so same story with this one. One of the equations is already done for you. So let's talk about that one. It's in a little bit of a different order, so let me just rearrange it. If you rearrange it into mx plus b, it's a little bit easier to identify. I just put the -x in front, the 8 to the right. It's the same equation. So the slope will be, remember the slope is the coefficient on the x when y is isolated. So m is -1, good. And b is 8. So what does it mean to have a slope of -1? So every time your independent variable changes, you go down by 1. Every time it goes up by 1, down by 1. So some students, when you have integers, they like to put the 1 underneath. So it tells you if you go 1 to the right, you got to go 1 down. And you start at 8. 1, 2, 3, 4, 5, 6, 7, 8. Count the grid lines. There's 8. And what happens when you go over 1? You got to go down 1. So you get pretty straightforward line. Over 1, down 1, over 1, down 1, and so on. And if I go left, I got to go left 1, I got to go up 1. Left 1, go up 1. So those are the grid points that will fit that window. There's infinitely many grid points. Just got so many that we can fill on this graph. That's why we draw a line with 2 arrows to say that this graph goes on forever. That's the easy one. Now the second one's a little bit harder. So let's take a look at the second one. Alright, so let's take a look at the term involving y. What's the coefficient on the term involving y? What's this coefficient, guys? So when I have a negative y value, I personally like to just move that one. That way I don't have to divide by a negative. Because what happens when you divide by a negative? Quinn, you with us? Put that thing in your pocket. pocket or something. Where's this -2? If you have to divide by a -2, then you're going to have to switch signs. It could probably introduce some problems. So I like to bring the -2 to the other side. So you have 2y on the left. So 2y will be on the left. That means the 14's got to move. So the 14's got to get up and go to the other side. Okay, take a look at mine compared to what it started as. Which two swapped places? Just the 2y and the 14 swapped places, and then just make sure when you swap over the equality that you change the sign. Now, what do we divide by to get y by itself? 2. So you got 3 halves x minus 14 divided by 2 is 7. So you don't have to have a fraction there. So where do you plot first? -7. So count down from the origin. 1, 2, 3, 4, 5, 6, 7. Nice dot right there. Now you have to go look at the slope to get the next point. So a positive slope, so you got to go 2 to the right and 3 up. So 2 to the right and 3 up. 2 to the right, 3 up. 2 to the right and 3 up. Oh, there's the spot on both. 2 to the right and 3 up. 2 to the right and 3 up. So the place that they meet, that's the solution. That point is 1, 2, 3, 4, 5, 6, comma 2. That's the solution. So then go check. If I plug in a 6 for that x value, 8 take away 6, 2. Perfect. It works for the first equation. It also has to work for the second equation. So plug in a 6 for the x, plug in a 2 for the y. 3 times 6, 18. 2 times 2, 4. 18 take away 4, 14. So you can always go back and check, make sure you did that properly. And then you can look at the instructions here, solve by graphing, then check. It's pretty fascinating stuff, eh? You guys good on this slide? Okay, the one underneath. I'm going to let you guys try this one on your own. I'm going to walk around. All right, let's take a look. First equation, I would move the 2x over by subtracting 2x on both sides. And then dividing by 3. So you start at 1. You go over 3 and down 2. So there's a whole bunch of points there for that line. Second equation. For this one, I would move the y and the 4. You just move the y over, move the 4 over. Analyzing that, you can see that the slope is 1 starting at -4. So you go over 1, up 1, over 1, up 1, over 1, up 1. Oh, there's the spot. Over 1, up 1, over 1, up 1, and so on. So there's the spot right there. That spot is 3, comma, -1. Go ahead and plug these into the original equations. Starting with the first equation, 2 times 3, that's 6. 3 times -1, that's -3. 6, take away 3, 3. And for x minus y, 3 take away -1, that's like 3 plus 1. This is 4. So that's the right spot. So next page we have a question about a group of students visiting the Head Smash and Buffalo Jump in Fort Macleod, Alberta. The admission fee, $5 for a student, $9 for an adult. So if one student goes, how much does that cost? 2 students? 3 students? So that is 5x, or 5 whatever, 5s if you will. So when I look at this, $5 for a student, I'm immediately thinking like 5s. What about $9 for an adult? 9a. I'd be like, if one adult goes, $9. If 2 adults go, $18. So you see how if you manipulate how many adults or students go, the result is some price. Okay? So like for that relationship, students and adults are the manipulated variable, and the 5 and the 9 is a rate of change. A rate of change. How much does the price change by each time S and A change by 1? Okay, so then they're saying, okay, in 1 hour, 32 people enter the center, and a total of $180 in admission. I don't know what this says. In admission fees. Admission fees, I bet that's supposed to say. Reminds me of that song. You don't want me to sing that one. No. Okay, so I have the sort of the brainstorming step here outlined with these white boxes. So let's go and take a look. So if you're going to let S represent the number of students and A represent the number of adults, what equation would you use to explain that there are 32 people there? Yeah, it's that simple. The adults plus the students, if you add them up, there are a total of 32 people. So there's one idea about people, and then the other idea is about cost. So we already talked about this. $5 for a student, $9 for an adult. If you put these together, 5 times the number of students plus 9 times the number of adults, that should equal a total of $180 because it's $5 per student, $9 per adult. So these are the two equations that you want to use. The stuff in between is a bit of a brainstorming step. So those are the two equations. Now we're used to x's and y's, are we not? So right here I'd be like, okay, x plus y, 32. I wouldn't try to do this with a's and s's, you just get a little bit messed up. So if we're saying that the x is the a, right? Here, can we just change this up a bit so that everybody's on board with me? Make sure yours is, hold on a sec, make sure everybody's on board with me. Let's keep the s first, the a second, so that we're all on board. So students is x. And adults are y. Okay, make sure everybody's on board with me so that we have the same stuff. So then you have 5x plus 9y is 180. You guys okay with that? Okay, so for the first equation, how are we going to isolate y? Move x over, so you end up with which equation? Negative x plus 32. Very nice. So there's one of them. Now the second one is a little bit harder. So the first step is to move the 5x. Move the 5x. Now what do we got to divide by? Divide by 9. So we got minus 5 on top of 9x. And then 180 divided by 9 is 20. So here's our two equations. Okay, so two equations. Let's go ahead and graph those guys. So we had x as the students, so let's put students down here. And we had y as the adults, so we have adults here. Now you only have so many grid spaces. So how are we going to do this? I think we got to count by twos. You see how we have 20 and 32? And we only have so much grid spaces, so let's go by twos. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. 32, 34, 36. So this will work. We can plot one y-intercept at 32. And where's the other y-intercept going to be at? 20. So we have two y-intercepts plotted. One of them's at 20, and the other one's at 32. So let's focus on the 32 for now. What's this slope saying? Negative 1. So if you go over 1, you got to go down 1. Well, we need a scale for the bottom axis. I think if we're going to go up by 2s on the y-axis, we should go up by 2s on the x-axis. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. So each grid is worth 2. So for this equation, negative x plus 32, if I go over 2, I got to go down 2. Kind of annoying, but whatever. Get it done. So that one's done. Over 2 down 2 is the same as going over 1 down 1. How about the next one? This one's going to be a little bit harder, because the way I've got my grid set up, and this is why when we go to the calculator tomorrow, this question will be a dream compared to trying to do it on paper. So like for this slope of 5 over 9, it doesn't go well on my grid, does it? 5 and 9. So I could just use a common ratio. Rather than use 5 and 9, double it up. Use 10 and 18, because that will work out nice. So if I go over 18, I got to go down 10. So 18 is going to be right here. Over 18 one more time and down 10. I'm way at the end here at 36. Didn't look like it crossed very nicely. So this is where you probably want to use a straight edge tool. So look like it crossed right about here. It's not very ideal. What do you think that point is, right where it crosses? I'm thinking it's halfway. 22, 24, 26. I'm thinking this is 27. And then halfway here. 2, 4, 5. I think it's 27 students, 5 adults. So this question here, actually graphing it by hand would probably be the worst possible solution. Like on technology, this question would be done in a heartbeat. And then algebraically, actually, it's even nicer. So let's just double check our solution. If I had 27 students, yeah, negative 27 and 32 would give me 5. This one I'll need a calculator. So I got to go negative 5 times 27 and then divide it by 9. Get minus 15 plus 20 gives me 5. So we got the solution. Okay. There's your assignment. It's in the textbook as usual. Good luck.